Hi people, what's up? Today we're going to go through a proof of tangents from an external point, and we're going to really think about how we develop a proof mathematically. So one of the key points in your SAT, if you look at the rubric, is development and testing of a valid conjecture. The first thing we're going to do is talk about how do we develop a conjecture. So imagine one day I went along and I decided to draw some circles, okay? Then I decided to, let's hope my battery doesn't die, put a point external to all these circles. So each of these circles have a point external to it. And then I decided to draw some tangents from that point to the circle. Okay, so here's a tangent. Here's another tangent. Here's a tangent. And here's another tangent. That's a tangent. Here's another tangent. And here's another tangent, okay? I decided to draw those, and then I was thinking, looking at them, and I thought, let's measure the lengths of these tangents, okay? So I don't have a ruler along with me, but I was like, okay, that's like the width of my hand. There's one hand. You can't read that, but that's alright, it says one hand. That's about another hand, okay? And this is about 3/4 of a hand. And yeah, probably the other one's about 3/4 of a hand as well. And maybe this one's about half a hand. And the other side is 2. So then I was looking at it and I was going, is there something interesting going on there? I reckon maybe that the length of tangents from an external point to the same circle is the same thing. That's the development of my conjecture. This is what I did. So from development, so this is one, first thing we got to do is develop. Then I'm going to produce a conjecture, okay? That's 2. Right here, 2, conjecture. So my conjecture is a proposition I put forward based on some observations, okay? So it's a prediction, it's a guess of what's going on over here. And it is that the length of tangents from the same external point to a circle is the same, is equal. Okay? So that's my conjecture, that the length of tangents from the same external point to a circle is equal. Okay. Now, I'm going to do the second thing. I've developed it, my conjecture, and now I'm going to test it. So if I was doing this properly, which I'm not, but I'm going to pretend I am, I would get something circular and I would draw a perfect circle. Okay, so just, this is a perfect circle. Not bad. And let's do another one. Yeah, not bad either, okay? And then I would draw in my lines, and I would actually get a ruler. I'll get a ruler, draw in my tangents and measure them, and say that's like 2.5 centimeters, and that's also 2.5 centimeters, and then this is say 4 centimeters, and this is say 4 centimeters. Okay, so I've now developed it, I've made my conjecture, and now I've got, okay, I'm going to draw it really accurately, I'm going to test it, it seems to work, but that's not a proof yet, is it? Okay, so let's prove it now. He doesn't flip. That's sad. Okay, you can burn that in your brains. I'm going to rub it out, sadly. I'm going to rub out my test. I'm actually going to rub out the whole thing. So I have room for this proof. It's not a hard proof, but it uses some stuff that you've done before. Okay, if you remember back in the day, you would have done congruent triangles at some point. Okay? What are congruent triangles? They're triangles which are identical in every way. And there's a few rules that we have to test congruent triangles. There's side, 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 if three sides are the same, if we have a right angle and the same hypotenuse and the same length of side, then we've got congruent triangles. If we've got side angle sides, so we've got two sides and an included angle. If we've got angle angle sides, so two angles and a side, or angle side angle, doesn't really matter if it's an included side or not, then you can say that the triangle is congruent. Okay, we're going to use that to be able to prove our little thing, our little tangent thing that's going on. Okay, I'm drawing my tangents and like that. Right. Now, so I know that I want to prove this using congruence because I've got to do something about congruent sides. So let's try and get in some congruent triangles. How am I going to do that? I'm going to put a center point and I'm going to draw some lines from the tangent to the center point. Now this should be ringing a bell. This bit here should be going bang bang. Radius tangent theorem. Remember that a radius is always going to be 90 degrees to the tangent. So I can draw in some lovely little angles. Okay, do I have triangles? Not really. Can I do this? Yeah, of course I can. Okay, I can draw a line. There we go. I've got two triangles. Now, are they congruent? Well, we have to prove that. In order to prove that, let's label stuff. Always important to label things so we know what's going on. Okay, label the 4 points. Now, let's think. Can I do side, side, side? Well, this is a shared side, and I've got some radiuses here, so they're going to be the same length. Okay, so I can go like that. But I don't have three sides, do I? So I can't use side, side, side. Can I use side, angle, side? I've got this side, I've got this side, and I've got that angle. But remember, side, angle, side, that's always going to be the included angle. Okay? Or the angle between the two sides. And this is the angle between the two sides that we know. Can't use side, angle, side. So side, 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 gone. Side, angle, side, gone. Angle, angle, side. I've got an angle there, an angle there. Do I know anything else? Not really. No. Okay, let's go there. So angle, side, angle, also gone, because I'm saying that we don't really know two angles. So that leaves us with right angle, hypotenuse, side. Do we have that? I think so. If you have a look, I'll bring you in closer, zoom, by moving the laptop. Right angle, hypotenuse, the angle the side opposite the right angle, and a side, which is our radius. Okay, so we've proved it. Congruent triangles proved. You could just write they're congruent triangles. No, you can't, okay? You've got to prove that they're congruent triangles using mathematical language. Listen up carefully. Okay, right angle, hypotenuse, side. Let's prove that these triangles are congruent. Okay, so we know that angle DCB is going to equal angle, so DCB is going to equal DAB, okay? Remember, when we do this, the letter in the center is where the angle actually is. So then we write our reason over here, given, okay? We know that. We know that equals 90 degrees. That's given. Okay, now we also know that side AC equals side, oh, that's not a side, that's an angle. Okay, side AC equals side DC. Why? Radius, or radii of circle. Okay, 2 bits of information. And then we know that BD is shared. Therefore, triangle, now when you're doing your triangle congruence, make sure that you name your triangle in the order of the angles. So what do I mean by that? Well, say we start at D, let's go to our right angle triangle. So we're going to go DCB, triangle DCB. We must make sure that we're going this way again, to the right angle triangle, so it's going to be DAB. Okay, is congruent to DAB. That's all that sign means. The equals with the swirl is congruent. Okay, and what's our reason? Right angle hypotenuse side. Beautiful. We proved it, sort of. You could just say, therefore BC is equal to AD. Not really. Just put another line, therefore AB is congruent to BC. Yeah, you can say that, but make sure you say a reason. Why? Because they're corresponding sides of a congruent triangle. So the corresponding sides of a congruent triangle are always going to be equal. Right. Corresponding sides of congruent triangles. Corresponding sides of congruent triangles, and so therefore the length of tangents, I'm going to say the lengths because it's bothering me, the grammar, the lengths of tangents from the same external point to the same circle are equal. Okay, so remember what we did and how you want to structure your proof when you're developing and testing a conjecture. Develop. Yep. Do a conjecture. That's the C bit. Test it. Prove it. And then finally say what you've proved. Enjoy!